Hey everyone, so we are going to take a look at how to collect the data for this lab. So I've got everything set out here in front of the camera, the things that we're going to be using. So let me show you how we get started. So if we look at data that we need to collect, we've got a couple of different pieces of data. The first piece of data is our mass of aluminum, okay? So here are our aluminum pieces. They're hanging out right here. We are going to figure out how we take a mass of them. Okay, so our thought might be, well, let's just put them on the scale, which would work, but when we do things in chemistry, so that we don't ruin our scales, we use what we call a weigh boat. So that's this thing right here, okay? It protects the scale if something that we're weighing is round or is something that might stick to the scale or damage it in any way. We can put it in the weigh boat, and then we're able to use the weigh boat to transfer that to wherever we need to do with it later. So when we get to more technical things that are requiring us to use like powdery chemicals, that's definitely going to be important. So we're going to start using it right now. So if I take this weigh boat, my first step is going to be to go ahead and put that weigh boat right on my scale, on my balance, and I'm going to use this tare button here, okay? Hopefully you've done this already. Usually you do it in middle school. I know, like, depending on what class you were in last year, you might have done it. You might have missed out if we were virtual. So I just want to make sure we all have it. So if I take my scale, it shows me right now that this is the mass of this weigh boat, but I don't care about that mass. I only care about the mass of the stuff that I'm going to put into it. So I need to tare the mass of the weigh boat. Tearing means I'm going to essentially ignore it. Okay, so now if you look at the scale, the numbers here went back to 0. So it's pretending like this weigh boat isn't actually on the scale. It's there, but the scale is ignoring it. So now I'm going to take my pieces of aluminum that are right here, and I'm going to go ahead and put them into my weigh boat, and then put that back up on my scale here. So you should see that I've got a mass of 5.33 grams. Okay, so that means that aluminum that I have in the weigh boat right now weighs 5.33 grams. So if it were me, I would go ahead and write that down in my data table. I'll show you a picture of the data table that I'm keeping here in a second, but I'm adding that number to my data table. Okay. Then we need to set up our graduated cylinder to do our water displacement. Okay, so you learned about water displacement last week when you were learning about how to calculate density. So in order to do water displacement, we're going to take, this is just a squirt bottle, it just has some water in it. It's a little bit easier to control how fast the water comes out if I use the squirt bottle. And I am going to use this graduated cylinder right here. This is a 10 milliliter graduated cylinder, okay? And I am going to fill it up to the 4 milliliter line. So I don't know how well you can see that on here. Here's the graduated cylinder. Okay, I'm going to fill it up to this 4 milliliter line right here. So, using my squirt bottle, adding water. I'm going to make sure that I measure from the meniscus of the water. So where it dips down in the middle, that's the spot that I'm looking for to make sure that I am at 4 milliliters. Okay, so that looks pretty well set up here. I'm not sure how well you can see it. I'll take a picture and put it on the next slide so that you can see exactly what that looks like at 4 milliliters. So I've got my graduated cylinder set up with the water in it. I've got the mass of my aluminum all ready to go. Now the next step is to figure out what the volume of this aluminum is. Okay, so you can see these pieces. They're a little irregular. Some of them are a little bit bigger, some are smaller, some are round, some are a little bit more oblong. Okay, so I can't calculate an easy volume of them. I have to use water displacement. So into my graduated cylinder, I'm going to dump those pieces of aluminum. I should see as I'm dumping them, the water level is rising. Okay, so my volume has increased here on my graduated cylinder. So let's see if we can get you to see this a little bit better. All right. So do you see where our volume was at 4 down here? We added these aluminum pieces to it, and now if I read from the meniscus, it looks like it's perfectly at 6. So that aluminum that I added 2 milliliters. Okay, so into my data table, you can see it, here it is. See, I'm filling out a data table as I go. So into my data table, I'm gonna add those new pieces of data. Whoops, still alive? Sorry, I dropped the camera. All right, so let's see here. For my final volume of water, for my initial volume of water, I've got 4 milliliters. That's what I filled it up to. My final water volume, I have 6 milliliters. Okay, so then to find the volume of aluminum by itself, I'm going to take 6 milliliters minus the 4 milliliters of water I started with. So the aluminum added 2 milliliters. Okay, and then, here, let me see if I can set this up where you can see it. All right, whoops. Oh, you're upside down. There we go. All right, so now you're looking at my data table. I promise I'll only do this for a second. I know it's a little shaky. So you can see my data table, and I'll put a picture of this in the next slide as well. But I've got the starting water volume of 4 milliliters. That's what I put in the graduated cylinder. I have my mass of aluminum that I found on the balance. I have my final volume of water, okay, after I added the aluminum to the water. And then I subtracted those to get the change in volume, which is my volume of aluminum by itself. Remember, I don't care about the volume of the water. It's just what helps me determine what the volume of the aluminum is. My very last step then is going to be to calculate the density. Okay, so my density is calculated by mass over volume. So I said my mass of aluminum right here is 5.33. My volume of aluminum is 2 milliliters. So mass divided by volume will give me density, 5.33 divided by 2. Okay, let me get my calculator out here. 5.33 divided by 2. All right, so I get a number of 2.665 grams per milliliter as a density of aluminum. Okay, so hopefully you can see where all of these numbers come from on my data table. I will put pictures on the next slides of all of them so you can see specifically the numbers on the balance, the numbers on the graduated cylinder, so you've got those pictures to see like you were collecting the data in lab yourself. Okay? For the next one, you are going to do this on your own. I'll get the pictures. You're going to fill out the data table. You're going to calculate the density. We are going to do copper next. And then our third one, you are going to have to do a little detective work, a little problem solving. So I am going to give you the work that somebody else completed, and you're going to have to go through and determine, did they do it right? Did they do it wrong? If they did it wrong, what went wrong? So we'll see if you can pick up on how somebody else does the lab. So again, next you're going to practice with copper, then you're going to do that detective work, that problem solving with zinc, and then both of those will be submitted in your understanding check form at the end. All right, good luck.